I'll double check that schedule, but tomorrow we have a quiz. We could do the quiz Wednesday because there's actually less to talk about tomorrow. Wednesday. Tomorrow is partial fractions. I don't know how comfortable you are with that. So, and there's only 4 problems. And you have a worksheet today along with 5, 6 in the book problems. So you can kind of put them together. I think there's only 4. Trap rule, I think there's only a couple. We're not doing Simpson's rule. Thursday, we're going to do improper integrals, part 2. Review part 1. We did part 1 in chapter 8. Friday, review, test Monday, Tuesday next week. I want to get through as much as we can before spring break. So have as little as possible. They're right over here. All right, let's do integration by parts. It's not too bad, but first off, we don't use integration by parts unless everything else we've tried to do an integral fails. Okay, Eric, please put your phone away. Okay, you guys, did you hear me? If a regular use substitution fails, then we'll go to this. This is a last-ditch effort. Do not do this first when you want to find an antiderivative. Always try regular use substitution. This is reversing the product rule. So what is the derivative with respect to x of f times g? I just want to make it a little simpler looking so you see what happens here. Can I do what? Nope, it's the product rule. It's the derivative of f times g plus g times the derivative of f. We're not doing that. We're finding a derivative. Oh, I screwed this up. Yeah, that's the same thing. Can't have that. So it's plus, then it's g prime f. Right? You show how it relates to integration by parts. And now, if I would like to get rid of this derivative on the left side, what could I do to get rid of that derivative? Integrate it. I know it doesn't look quite right, but that's okay. Okay, guys? Are you ready? What's the integral of the derivative of f times g? Eric, please put your phone away. It's f times g equals the integral of f prime times g plus the integral of g prime times f. It doesn't matter which one you solve for. It makes no difference. So I'll just solve for this guy. Doesn't really matter. So the integral of f prime g is equal to the product of the two functions minus the integral of g prime f. So it's reversing the product rule. So what it looks like in differential form, it's u dv. So this is going to be the dv, and that's going to be the u, is equal to u times v minus, and then that's going to be du, and that's going to be v. You're going to memorize this. The integral of u dv is equal to the product of u and v minus the integral of v du. Could you have these two integrals reversed? Absolutely. It doesn't make any difference. So I'm going to have to do an integral. So let's see how we apply it. Why is the integral what? It's the derivative of fg. What does an integral do to the derivative? Cancels it out, so it's just f times g. So what this is just the product rule. So if I want to integrate, and maybe later on, but I want to integrate the log of x. And you can try a regular use substitution, but it's going to fail. Because I don't see the derivative of the log function there. So let's try integration by parts. I have a function u, and I have a derivative, dv, or differential actually. So I have to figure out which one I want this to be. No? If I make this my derivative, that means I have to integrate that, and I don't know how to integrate that. So that's not a good choice. So instead, I'm going to undo what I just did, and I'm going to make this my function That's the u part, and there's the derivative. So how I do this, then, is I label them. I write down that u is equal to the log of x, and dv is equal to dx. It's just it's product of u times v. They just use that as standard notation. You want. Doesn't matter. We're going to, because it's like a u substitution. So what's, now, this is going to be equal to u times v minus the integral of v du. Hopefully that integral I can do. It's just a way to undo the product rule. I have nothing to undo the quotient rule. Not to say it doesn't exist. I don't know what it is. Okay, so I'm just going to plug it into this equation here, because that's what that is. What's du equal to? 1 over x times what? Dx. Those differentials are really important. They won't mark it wrong on the exam, but you really should have them. So how can you do this? If dv is equal to dx, if you integrate both sides here, what's this end up giving? What's the antiderivative of 1 dv? It's v. It's the antiderivative of x. X. Okay, now I'm going to use the formula. So it's u times v minus the integral of v times du. You'd be surprised how many people with their calculus remember this formula. Okay, what's u times v? Well, there's u. We'll do a bunch of these, and you'll catch on. And you'll say, oh, it's not bad. It's just memorizing a process. So it's u times v. So it's x times the log of x minus the integral of, and v turned out to be x, and du turned out to be 1 over x dx. There's your product. I'm undoing the x log x. So I get x times the log of x minus the integral of, what's that going to give me? What happens to x's? It cancels, so I'm going to get 1 dx. So it's x log x minus x plus c. That's the integral of the log of x dx. How do you know if it's right? Take the derivative of this product. The derivative of the product is x times the derivative of log of x, which is 1 over x, plus the log of x times the derivative of x, which is 1, minus the derivative of minus x is minus 1. I didn't say that very well, but I think you got that. So it's 1 plus the log of x minus 1, and it's the log of x. You see, it works. But I don't want to do this method unless I absolutely have to. If a regular U substitution fails, then I'll do this. By the way, this will work even if a regular U substitution works. It's just ugly. And some of you will choose to do that on your tests and will drive me crazy because I got to follow through your work. But it can be done. But I'd really rather you didn't do it. So when do you do this? You use integration by parts when you can't integrate what you have, like the log of x. What else can I integrate? Can I integrate the inverse tangent function? No. I cannot integrate e to the x cosine of x. That's a tricky one, a little bit beyond what we're going to do here. I think I might have as an assignment, but they will never ask it to you in the exam. So there's a table over here to help you. Here's the problem. How do you decide to make which part u, which part dv? That's why it's called integration by parts. Okay, listen carefully, guys. Choose u to be functions when you differentiate them. They either go away or they change their form. Like the derivative of the log of x changes its form. In fact, I never thought about this. If this is u, then what would du be here? This would be 1 over x dx. What about the inverse sign? It really changes form. I don't know how to integrate any of these. That's another reason why I don't want them to be the dv. So this is 1 over the square root of 1 minus x squared dx. Inverse cosine is the same as inverse sine, but it's just the negative of that. Kind of silly, isn't it? What about the inverse tangent? 1 over 1 plus x squared. So you have this in front of you now. And then the derivative of x to the n becomes nx to the n minus 1. It's going to go away if I differentiate it a number of times. The choices I use for dv are those that, if I integrate them, they just change, they don't really change form. If this is dv, then what's v? This is e to the x. If I differentiate that, that's not going to go away. It's not going to change form. I want it to change somehow. How about the integral of sine of x? Negative cosine of x. Well, that's just the shift. Still the same as sine. No, we're integrating now. This is dv, then this will be v. What's this one going to give you? Sine of x? Oh. Did you know you can do the tangent? Yep, we're integrating the dv's. This is negative log of cosine of x. No. You do not need to do integration by parts to integrate the tangent of x. I think I did it right, because the integral of the tangent is integral of what function? Sine of x over cosine of x. Will a regular u substitution work? What would you like u to be? Might as well do it. It's a teachable moment. That's right, cosine of x. Then what's du? Negative sine of x dx. Was that in the homework or not? I don't remember. Okay, substituting that in, this is going to be a negative du, and that's going to be u. So I'm going to get the integral of a negative 1 over u du. What is that? That's right. It's negative log of the absolute value of u, and u was the cosine, so there it is. So we can integrate that. Not that I want to. I probably actually would rather put the tangent maybe into the u side where I take its derivative. One part of your integral you'll differentiate, the other part you'll integrate. I don't know how to integrate the log, inverse sine, inverse cosine, inverse tangent. So those are going to be the u's, because I know how to differentiate them. So let's do a problem. You've got a bunch of problems to do. I did the log of x. Let's do a different one. How about that one? If you try regular u substitution, it's not going to work because you don't see the derivative of the inverse sine of x. So there's two parts here. You have inverse sine of x, and you have a dx. You see the two parts? One's going to be the u, and one's going to be dv. Sorry. I don't know why it's doing that. So what do you want sine of x, inverse sine of x to be? U. Because I want that to go away. If I make this whole thing dv and the other part to be 1, I'm in trouble because I can't integrate it. So that's why I'm not going to do that. So this is dv. Oh, I didn't give you a whole lot of stuff, did I? Let's move that up here. So we could do something off your worksheet, or we could do things right out of the book. I don't care. So now, the formula is x isn't v. Oh, yeah, well, I'm going to write it out here. U is equal to inverse sine. Then du is equal to 1 over the square root of 1 minus x squared. Right? And you need the dx's there. So dx is equal to dv. So x equals v. Actually, that's kind of backwards. What's the formula? You guys memorize it yet? It's kind of a sing-song thing. uv minus v du. So u times v is v times the inverse, x. X times the inverse sine of x minus v, which is x, times du, which is 1 over the square root of 1 minus x squared dx. Can we integrate that? Because without the dx, you don't have a differential and you can't do an antiderivative. I'm going to have to do a regular u substitution. Yeah, sorry. There, oh, that worked. So the first part's going to stay. Now, you want to change letters, or are you okay with using maybe a different color U? How about a different color U? I don't. It's not the same U. What do you want U to be? 1 minus x squared. This is a regular U substitution. So what's du? Negative 2x dx. Okay, so I have the integral. Well, I have a negative sign there, so guess what? I got the negative. What should go in front, though? You did the homework for today. It should be easy. 1 half. But the negative's going to cancel with that negative, right? So it's going to become plus. Let's just write that part down there. And then it's x dx is du over the square root of u. How do you integrate that? Yeah, u to the what? Not positive 1 half. Negative 1 half du. And so that antiderivative becomes, see, it's negative 1 half times u to the 1 half divided by 1 half is the same as times 2, correct? Okay, so I'm going to have x inverse sine of x minus, and then I'm going to have this thing. So now let's keep in red. Yes, I just didn't want to do it too fast. The 1 half goes, so it's negative square root of u. What was u? 1 minus x squared plus c. Sometimes you have to do integration by parts twice. How did I get rid of what? This is a negative from here, and that negative makes it a plus. No. This is equal to this. Let me circle it. That's the negative still. Then this becomes u to the positive 1 half times a positive 2. Because that negative came from this du. What's going to happen? This negative and that negative. They'll cancel. As long as you get plus eventually, I don't care where you do it. I wanted to just focus on the integral. But it doesn't matter. I could have taken care of the negatives right away. So should we do a problem right out of the homework? I'd rather you do the homework first. The worksheet is, which I want you to do, but it's AP. It's exactly what you're going to see on the AP exam. Maybe. And problem question 2 is out of 5-4. And question 3 looks like possibly just a regular U substitution. Now, number 4 is integration by parts. I mean, I don't remember what 3 is. But let's do some simpler problems. Those are a little harder. We are skipping 5-8. And what's the first problem I assigned? You need to do more? Do more. Number 3. Or should we do 4 because you don't have answers for 4? What do you do online? I think we should do 4. Or should we do them both? Should we do them both? 3 and 4? Yes. Because number 3 is pretty straightforward. This is a homework question, yeah. That's homework too. But I would suggest you do the book problems first. Well, you can try a regular U substitution. It's not going to work. So which one do you want to be U, and which one do you want to be dV? Remember what I said. Which one should be, because this works, and there's a mnemonic for it, but I don't ever understand it, so I don't do it. You want the ones that are going to go away when you differentiate them to be your U. So I want U to be X. So I want dV to be those things that if I differentiate, they don't really change form. They don't go away. Well, tangent could give me secant squared. I don't know if that's going to help me. And you just have to do it. So u is x, then this is dv, right? No? That would be even harder. Because then what's the derivative of x times cosine 5x? I have to use the product rule. What? Because if you look at my little chart, I said you want u to be the one that goes away. The x is the problem, not the cosine. So if u is equal to x, I'm going to go back again. I want u to be the one that goes away. The power rule. These are what I want to be u. Because if I do it the other way around, then the antiderivative of x is x squared over 2, and things get worse. But if I make this be dv, I'm going to have x squared over 2. Things have gotten more complicated. What did you say, Eric? Yeah, you always want your these trig functions to be dv. Well, sine of 6x, we'll have to think a little bit, won't we? Right. Yep, if you look at the front, it says right here, these are what I want to be dv because I can integrate them. Right. Okay, what's du? Let's do the easy one first. dx. Well, I can do it without a u substitution. Guess and check. What's the antiderivative of cosine? Sine of 5x. Now, if I take the derivative of sine of 5x, I'm going to get times 5. I don't have times 5 here. So what do I have to do? Divide by 5. If you need to do another u substitution to see that, then do that. Now, is that going to work? The derivative of sine of 5x is cosine of 5x times 5, but I have a 5 here, cancels out. So now we just put it in. No, if you say dv is this, you integrate. So it's u times v. So it's x times the sine of 5x over 5. That one's okay. Minus the integral of v, which is the sine of 5x over 5. And lucky day, what happens to u? What happens to x? Its derivative is 1. Had that been x squared, guess what? You'd have to do it twice. If this were x squared, then you would have times the 2x here. Then you'd have to do integration by parts yet again. They won't, yes, it does, but it's not going to happen on the exam. The 1/5? I mean, there's no 2's. So this is times dx. I'm going to pull the 1/5 out. That's right. So this is x times the sine of 5x. There's the product rule. That's all you're doing is it's the product of those two functions. Minus 1/5, and that's the antiderivative of the sine of 5x dx. Now, you guys are pretty experienced. I would hope that you can do this antiderivative without that extra little u substitution. But if you need to, go ahead. Yeah, but they're all different u's. Yes. What's the antiderivative of the sine? Remember, I'd be lost without you. Negative cosine of 5x. Now, what's wrong with that? Hey, Nick, if I differentiate this, I still have to have a 1/5 there. So if I took the derivative there, the 5's would cancel. I don't want that to happen, so what has to be divided by? Has to be divided by 5. If you let u equal 5x, then du is 5 dx. And if you solve for dx, it's du over 5. That's why I have an extra 5 there, plus c. So it's x times the sine of 5x over 5 plus 1/25 cosine of 5x. If you do another U substitution, do it. I got the C. Let's do number 4. You will see this on the exam. I've seen it in the free response, by the way. I have seen it in the free response. If it's in the free response, it's worth a couple points. It is. What? Oh, yes, it is. You can, but this is the double bubble one. Okay, you guys? You guys? No, this is the double bubble one. This is where it will occur. Let me explain. Okay, guys? 60% of your exam is AB. So they already have 60% of the multiple choice will be AB questions. That's the first score. I'm saying 60% of your exam. No, if you get a 60% on the exam, you're going to get a 5. Okay. Zach, let me explain the double bubble. Okay, guys. Okay, 50% of the multiple choice is AB. I'm sorry, 60%. And 40% is BC. Well, how do they fix that problem on the free response? You have 3 ABs and 3 BCs. That's 50-50. But it's got to be 60-40. So what they do is they take one of the BC ones and they take 4 points out of that and put in BC topics. So this is the way they would do it. Integration by parts could be in the free response in that little piece that's BC. Usually it's this with the differential equation, and the diff EQ is the AB part. And then we have to fill in 2 bubbles on the bubble sheets. That's why we call it the double bubble. Okay, let's see if you can do this one. Zach, do you know what I want you to be? What do you want you to be? Okay, turn your paper over, look at your table. I want it to be X. Then dV is what? E to the negative X. That negative is going to cost me some problems, but not too bad. So then what's du? 1 times dx. Now, what's the antiderivative of e to the minus x? It's e to the minus x, but that's not quite right. Yeah, slap a negative out front. Is that right now? How do you know if it's right? Take the derivative. That's negative e to the minus x times the derivative of minus x. Yeah, that's right. So it's u times v. Those of you who have older brothers or sisters, ask them what the formula is for integration by parts. They'll be able to tell you, I think. Ask Mr. Adney, because he was a math teacher. So it's u times v. So it's x times e to the minus x minus v du. I'm sorry, what? That's the negative. Thank you. Now this is minus from that negative. And v is negative e to the minus x, and du is dx. That made that much easier, because I can do that one. Now, I can do a u substitution, but I mean, I hope you can look at that and see. This is minus x e to the minus x. What happens to the two negatives? Plus, what's the antiderivative of this guy? E to the minus x times what? A negative 1. Is the derivative of e to the minus x positive? No. So your answer will look like this. And if I have time on the exam, I'll probably redo it. And not redo it, but take the derivative and make sure it works. It isn't e to the x to the negative 1. It's e to the negative x. Because what's the derivative? Remember, I took these two and made them plus, okay? I took care of that. Probably not a smart thing to do, but I did. What is the derivative with respect to x of e to the minus x? It's e to the minus x times the derivative with respect to x of minus x. But when I integrate it, I can check by differentiating my answer. And if I don't put the negative 1 in, then the derivative of this does not equal that. I'm off by a factor of negative 1. Nick. Doesn't matter. C is a constant. Arbitrary. I don't even know what it is. Have fun doing it with the limits of integration. Okay, so try these. You want to do the last one on here on this little worksheet? Or try doing, we almost did number 1. And number 2 should be easy. I believe number 3 I do have to have integration by parts. Do you need me to do any more with you, or do you have it? Think you have it? So one way you really know, practice. I think I have answers up for this.